In this video, we can go through inequalities, and here we are going to see how to solve inequalities in pure mathematics, and we are going to see those methods which we are required to use when we are solving inequalities in pure mathematics. So here let us begin by looking at this, that an inequality is a logical statement that states a relationship between two mathematical expressions. Okay, so an inequality is simply a logical statement that states a relationship between two mathematical expressions, and by doing so we always use these inequality symbols. There are 4 of them. One is less than, the second one is greater than, the third one we have less than or equal to, and then the fourth one, which is the last one, it is greater than or equals to. So whenever we are tackling indices, we shall be using these basic inequality symbols as we go on. So, but now I want you to take note that when we are solving equations, either quadratic equations or equations of degree 3 or degree 1, those equations we could get values of like x or y depending on the unknown, and those values they used to be unique. Like for example, x is equal to 0, x is equal to 2, x is equal to negative a third. Those are unique values, and those are the values which we get when we solve equations. But however, when we are solving for inequalities, the solutions which we get, they are simply range of real values. So the solution is a range of possible values, and those values are always what? Real. So we are going to see how to solve, and mostly that is the new thing when you come to A level. So here let us first go through. Remember, we have 2 types of inequalities. We have linear and nonlinear. So for us, we are going to go through nonlinear inequalities. The linear inequalities are the ones which we looked at the ordinary level, but let us go through nonlinear inequalities because they are the ones which are involving more complex and new steps. So here, let us go through nonlinear inequalities which are in one unknown. So here we are saying there are several approaches. There are several approaches used for solving nonlinear inequalities. But from time to time, only 2 of these will be employed. Meaning we have many steps, but we are going to buy a few of them. But remember, here we are saying that there's a graphical method and there's sign change. But so specifically here in this, we are going to be looking at the sign change. Graphical, we will not concentrate on it a lot. So we can just leave graphical aside. We are going to go through the one which we use sign change. So here, like we can look at this one here. They're saying that when using sign change method, a table describing specific regions of the inequalities is used, and the necessary tests are performed. So here we are going to see we use the table, but within that table we we use sign change method to come up with the correct range of values of what? Of x. So that's why we are saying like this. So we shall be testing like the way you tested for inequalities at O level, that like shading the wanted and the unwanted what? Regions. So here we shall be again testing like that. Now we are saying that if the inequality symbol is less than or equal to or greater than or equal to, care must be taken because the critical values of the function and numerator in case of fractional functions will always satisfy the what? The inequalities. So we will see this when we come to the examples, and here like we can be able to see the examples here that saying solve the following inequalities. So when they say solve the following inequalities, we have a 2x squared minus 3x plus 1 less than or equal to 0. Then B, we have 7x squared greater than 1 minus 6x. And then C, we have 2x cubed plus 3x squared greater than or equal to 2x. We are going to see how to solve these ones using sign change, not graphical. Okay? And we are going to be able to get the range of possible values of x in all of these three questions. So here we are going to go through these ones here and we get the answers. Okay, let us solve these inequalities in the example, and here we can begin with the first one, which is part A. Part A says 2x squared minus 3x plus 1 is less than or equal to 0. So this one, since it is already organized, all the terms are on one side, then it means that we can just factorize. And remember, it is a quadratic expression, so you look for the sum and product. Say that you factorize out it, say that it looks like this. Say that it is in 2x squared minus x plus 1 less than or equal to 0. And then after that, do the factorization, 2x into x minus 1, and then there also minus 1 into x minus 1 equals to 0. Equals less than or equal to 0. Then after that, you combine the two brackets, which is x minus 1 and then 2x minus 1 less than or equal to 0. So what you have done at this part, it is simply factorization. Now after factorizing, say that now we have expressed everything in as factors here, then we can be able to get the critical values of x. So the critical values, we equate each bracket to 0, like for example x minus 1 equal to 0, and there we get x as equal to 1. Also we equate the second bracket to 0, which is 2x minus 1 equals to 0. So equating it to 0, we get the value of x as a half. So meaning the critical values there, we are having x equals to 1 and x is equal to a half. After that, then we are going to illustrate them, because remember we are going to go to the table. So we use these critical values of x to come up with these range of values of x. So whereby the two critical values are half and 1. So we create the ranges of x values. Like for example, we have this one here, we test the region. There's that region which is below the smallest value, which is a half. That is x less than or equal to a half. The second range, it will be from a half up to 1. That is a half less than x less than 1. Then another one, which is the last one, it's the last one, which is x greater than or equal to 1. So meaning here we have three ranges of values of x. And in these ones, we are going to go to the table. We are going to come to the table here, so that we test for the signs to come up with the correct range of x values. So the corresponding signs in the respective regions can be analyzed using the following table. We have region 1, region 2, and region 3. So region 1, it is for x less than a half. Region 2, a half less than x less than 1. And then region 3, x greater than 1. So and then in this column here, we write our factors. and the two factors are x minus 1 and 2x minus 1. Then the overall, it is x minus 1 bracket, another bracket 2x minus 1. They are multiplying each other. So in region 1, I can pick a value like which is less than a half, and that value I can pick like 0. Then after picking 0 there, I substitute in this the first factor, which is x minus 1. So 0 minus 1, you get negative 1. But our point of interest, you only write down the sign. We are only interested in the sign, so you leave out 1. Just note, is it positive or negative? Then also when you substitute in the next one here, when you substitute there, it's still 0, you get again a negative answer. So also you just write negative. Then again to get here, you get the sign, the first sign times the second sign, it gives you positive. That's negative times negative, you get positive. So the overall sign here, it is what? Positive. Then in region 2, we pick a value of x which is between a half and 1. Like for example 0.7. So when you substitute in the first factor, which is x minus 1, 0.7, 0.7 minus 1, you get negative answer. So that's why here it is negative. Then when you come to the next one here, the next one, 2 times 0.7 minus 1. When you substitute there x as 0.7, there you get 2 times 0.7 minus 1, which is 1.4 minus 1, and there still you get a positive value, 1.4 minus 1, it will be positive. Then after that, negative times positive, you get the final value here as what? As negative. Then the third region, we pick a value of x as x, which is greater than 1, like for example 2, and then we substitute in the first factor there, which is x minus 1. 2 minus 1, we get 1, which is positive. Also here for the second one, 2x minus 1, 2 times 2 minus 1, we get a positive answer. And then positive times positive, we get the final value here, which will be what? Positive. Then after that, after this table of ours, we can say here that since the critical values satisfy the equation, they are all solutions of the what? Of the inequality. Okay, so meaning now, hence the solution set for this inequality, for this overall inequality, which is x minus 1 bracket again 2x minus 1 less than or equal to 0, the correct range of x values, it is in this second one here, this second one. Why? Because the overall sign here, it is negative, and remember this inequality is saying less than or equal to 0, so meaning either giving 0 or less than 0, so meaning it has to be a negative what? Answer. So it is this range of values of x, which is from a half up to 1. It is the one which is agreeing with this inequality. So because it is negative, that's why we are using it. I mean, that's why we are saying it is the one which is right, because it is giving a overall value as negative. Whereas the rest, these ones positive, these ones they disagree with the inequality. Okay, yes. Then after that, why are we including here less than or equal to? It is because even a half, when you put here a half as x, the answer you'll get here 0. Also when you get this one and you put here as x, again also you'll get what? 0. That's why we are saying x is from a half up to 1. They are all inclusive, and this is the solution set for the first question there, which is A. When you come to B, still it remains the same. B, here you are given 7x squared plus 6x minus 1 greater than 0. So still here you have to factorize out this. So you factorize out this so that you get factors on this side here, and the factors we are having x plus 1, another bracket 7x minus 1 greater than 0. So the critical values of x here, when you equate these two brackets to 0, the critical values will be x is equal to -1 and x is equal to positive 1 out of 7. Then after that, -1 is less than 1 out of 7. So meaning our table here, the range of x values, the first one to be x less than -1. Then after that, the next one to be -1 less than x less than 1 out of 7. And then after that, the third region is in x greater than 1 out of 7. They should be in their order, in ascending. You begin with the smallest up to the highest. Then these are our factors which we factorized, which we got up here. Okay, these factors here. So you write them here, and then still you will test like they will test the other one. X less than -1, we can pick here like -2, and when you put here -2, -2 plus 1, you get a negative answer. So we write negative sign. Also here, -2 times 7 minus 1, also we get a negative answer. Then after that, negative times negative, we get what? Positive. Then negative, between -1 and 1 out of 7, in this region here, we can pick 0. When you put here 0, when you put 0 in the first factor, you get positive answer. When you put 0 in the second factor here, you get x as negative. Then positive times negative, we get negative. And then lastly, beyond 1 out of 7, in that range there, we can pick like what? We can pick 1. So when you put in the first factor there, we get positive. The second factor there, we get also positive. So positive times positive, the overall answer there, it will be what? Positive. But remember, this inequality here, it has to be only a positive value. Okay, like there you see here. For that greater than 0, it means that the answer has to be positive. So therefore, the solution set, it is x less than -1 and x greater than positive 1 out of what? 7. And here the critical values are not part of the what? Of the solution. Why? Because like when I say I put here x as -1, it will give me 0. But 0 disagrees with this inequality. 0 is not greater than 0. So meaning they are not inclusive. That's why we just leave them just like this. X less than -1. Not x less than or equal to -1. Okay. And then x greater than 1 out of 7. But not x greater than or equal to 1 out of 7. Why? Because these critical values are not part of the solution because of this inequality. This inequality is just saying greater than. So that value has to be just positive but not also 0. So that's how we can work out part what? Part C says 2x cubed plus 3x squared minus 2x greater than or equal to 0. So here, when you check, we can be able to see the common factor in all of them, which is x. So we factorize out x into bracket 2x squared plus 3x minus 2 greater than or equal to 0. So that after that, we can be able to factorize what is inside the bracket. And when you factorize it, we get x into x plus 2, another bracket 2x minus 1, which is greater than or equal to 0. So mostly the real work is around here. You have to be knowing how to factorize any quadratic expression if you are to work out these questions here effectively. After that, we find the critical values of x. The critical values, we equate all these brackets, all these brackets to 0, so that we get the first one, which is x is equal to -2, another one x is equal to 0, and then another one x is equal to a half. So either x is equal to 0, or we have x plus 2 is equal to 0, and then we have 2x minus 1 also equal to 0. So they lead us to these three critical values: -2, 0, and a half. So those are the three critical values of x. Now when you arrange these critical values, you find we have four ranges of values of x. We have the smallest value, which is -2, followed by 0, and then lastly by a half. So we look at that region which is below the smallest value, which is until be x less than -2. The next one to be from -2 less than x less than the next critical value, which is 0. Then after that, from 0 less than x less than the next critical value, which is a half. Then after that, we also test that region beyond a half, that is x greater than what? A half. So after that, we have our factors here written here on the left hand side of our table. So we have the first factor is x, the second factor, remember we are getting them from here. So the next one, it is x plus 2, and then the last one is 2x minus 1. So we come to this region here, we pick an x value, like for example -3, it is less than -2. So meaning, what is x? -3, and here it will be negative. Then when you come to the next one, -3 plus 2, you get negative answer. Then when you come here, 2x minus 1, that is 2 times -3 minus 1, we get again a negative what? Answer. And then after that, negative times negative times negative, we get negative. Okay, we get negative here as the overall sign. Then between -2 and 0, here we can pick like -1, so that now still x is negative. -1 plus 2, we get positive. -1 times 2 minus 1, we get negative answer. So negative times positive times negative, we get a final sign as what? Positive. Then between 0 and a half, we can pick like a quarter, like 0.2 or 0.25. X will be positive. 0.25 plus 2, we get positive answer. 2 times 0.2 minus 1, that is 0.4 minus 1, we get a negative answer here. So positive times negative, we get the final sign as what? Negative. Lastly, we test that region beyond a half, and we can pick, for example, 1, x as 1. So the value of x is 1, x is 1. When you come here, 1 plus 2, we get 3, which is positive. Then 2 times 1 minus 1, we get again a positive value. So the overall sign is there, positive times positive, we get the overall sign as what? Positive. So that is after the table. After the table, you come here, we are saying that since the critical values satisfy the equation, comma, therefore they are part of the solution. Okay, because the inequality here is inclusive, greater than or equal to. So meaning whether we put there x as 0, or we put here x as -2, or we put there x as a half, all of them, they will agree, they will give 0. That's why that we are saying that they are also, the critical values are, they satisfy the equation, so therefore they are part of the solution. So we come here that hence this inequality here. Remember, this inequality is that inequality up here. Okay, so therefore hence this inequality, its solutions are, that is, remember, it is greater than or equal to, greater than, positive. You see this one here and then this one here, both of them are positive. So meaning their sets, these ones here, their sets are the ones which are going to be the solution sets, which is the first set is this and then the second set is this. Why? Because they are giving positive results here, positive, like there you can be able to see here. Okay, so but remember, these critical values are inclusive, either 0 or a half or -2, they are inclusive. So that's why the solution set is -2 less than or equal to x less than or equal to 0. So we are getting this one here, but remember we modify it because the critical values are also inclusive. So that's why we have to add there by saying less than or equal to. And then this one here, it is a half. That is x greater than or equal to a half. There's simply some small mistake there. Here it is x greater than or equal to a half, like this. So that is the thing there. Then after that, I will expect you to look at to do some, to also some numbers here you can try to work out, so that you can be able to, like, for example, you are given this one here, that you work out this, find a set of values of x for which, yes, I'll expect you to get the answers to these ones here, and we meet in the next session.